And we have sound. Alrighty. Boys and girls and ladies and gentlemen, I'm not going to waste any time because we've got not very much to cover and a lot of time. No, wait.
Right.
Yeah, I know. There we go. So this is a magnet, and see if I put too much water in there. I can put this guy in there like this, and that's not quite enough water. But this is something that people noticed was that with magnets, you could float a magnet or hang it from a string, or, you know, hello? This does not want to work. There we go. Is that working? Almost working. I'm trying to get something where it can like orient itself. There we go. There we go. People noticed. I think that we need a little applause here. We have some friction, right? But people noticed that that a magnet in a dish, okay, if you'd float it on water or hang it from a string, that magnets were these things that had this property where they would point north. There we go. In fact, we call the end of the magnet that points to the North Pole magnet. So there are two poles of magnet. There are South Pole and there are North Pole. And the North Pole is the part of the magnet that points to the north. Okay, so that is concept zero. Yes, sir?
I believe your directions are reversed.
Yeah, well, you got to understand that this thing is pointing that way, right? So the projector flips everything around. Yeah, there we have it, right? So this thing really is pointing this way, and there is more friction than I would like. But I think you can see that if I disturb it, that it will orient itself. And then the other thing you might notice is that it's pointing a little bit to the side. That's probably because there's metal in the projector. The other reason is that around here, due north is like that, but really it's not pointing toward the axial pole of the Earth. It's actually pointing toward magnetic north, which is in like northeastern Canada. Yeah? And so in these parts of the country, when you use a compass, you actually, a little applause for this one. In this part of the country, you have to actually point it something like 17 degrees off of that. So we can set it like this and go like that. I think that's how it works, right? And again, here, this is a compass. And I suppose it's got like glow-in-the-dark stuff or whatever. But again, the part of that needle that points toward the north is the North Pole magnet. Okay. So what you can do is you can use this if you have an unknown magnet. You can use this to find the polarity of something, right? So if you've got some unknown magnet, I present to you an unknown magnet. Okay. It doesn't have the poles marked, right? One way to find it is to look and see if like one end is marked north. Huh? There we have it, right? Okay. The other way to do it, though, and I'll use these compasses because these guys are a little easier to figure out. This one's got a little cutout on the north, so it's better for projecting. Okay. But the North Pole is pointing that way. Again, the projector sort of reverses it. But if you take an unknown magnet, what you do to find out the polarity of this magnet is I bring it in from the side, from a distance. Notice that as I bring that magnet in, which pole likes this side of the magnet? The North Pole likes it, so that side of the magnet must be a South Pole, yes? Okay, and if I bring the other side in, I'm going to flip it around. It's like, ooh, there it is, right? You have to be careful if you bring it in too fast. Some magnets are strong enough to I can just attract any side of the magnet, because ultimately the magnet is a piece of metal, and I can just suck any side I want into the magnet, yeah. Well, that's an interesting thing, right? You know, it's like, it turns out that magnetism is like the grain of the wood. So if I were to take this magnet and cut it in half, this side is north and this side south, for example, maybe, right? But if I cut it in half, it's not that I'll get a monopole of north and south. It's that I'll get another thinner magnet, each with a north and a south pole, right? So what it is that that this thing is made up of billions and billions of molecules, right? And ultimately, the iron atom itself has a net magnetic moment, and why that is, we'll learn today. Yeah. No, it's just the magnetism is just an alignment of all those atoms, a net alignment of all those atoms, and so cutting it doesn't change that alignment. It all has that alignment, right? Such that the top is always north and the bottom is always south. Yeah? Isn't that weird? Okay, so anyway, if I bring in an unknown magnet, I can do that. Here's a bigger one. This is kind of fun. We can try that. There's the North Pole. This one has enough friction that it's, it's not going to just suspend itself like that. But I can take, and this is why magnets are so much fun, right? I can take the North Pole, and it's like, South Pole likes that end there. Right? And then I can make a motor. There we go. Oh, look at that. Okay. Or you can have like a remote control. It's like, there we go. I just like that. I don't know. I like that. Isn't that fun? Okay. And then we've got what's going on here? Oh, I got a magnet in my mouth. This is a cow magnet. Yeah. It's like back in the day when you couldn't get cheap, really strong magnets. Like now I just have to wait for a hard drive to die and I can get really super, super strong magnets. But back in the day, cow magnets were good, cheap, strong magnets. Do we know what cow magnets are for? They're for cows. That's why they call it a cow magnet, right? But why does a cow need a magnet? Well, because it gets boring out there. Right? They need something to play with. No, it's it's hard to be a cow. You're just eating grass, getting milk all the time, right? Okay, no. Cattle they just eat stuff on the ground. Okay, and so if you leave little bits of metal on the ground, like little bits of barbed wire fence is like the worst stuff, right? They will eat that metal. Yes, and it's not a problem in their stomachs. Stomachs are big, tough, muscly things, right? Apparently, it doesn't hurt their stomachs, and they have 4 of them. But it does hurt the intestine. If you get the metal into the intestine, sometimes it'll snag or something like that, right? Okay, and so what they do is they put a magnet in the first stomach, and apparently the magnet is heavy enough that it doesn't get passed on to the intestines. It just sits in that first stomach, and then all the metal that the cow eats sticks to the magnet. Yeah, and then apparently, I don't know. Do you every now and then take the magnet out and clean off the metal, or I really don't know. There's a job I wouldn't want. Because they just eat stuff on the ground. They're not the smartest. They're not dumb. They're not dumb. They're just not the smartest animal on the farm. Smarter than chickens. No? Yeah, no. Smarter than chickens. So anyway, this is a cow magnet. That's what it's for. There you have it. And then while I'm talking about that, something that's more dangerous than you might think of, a lot of toddlers have died because they'll eat. You never ever want to let toddlers play with toys that have little magnets in them. They make these. And I know this because my wife works at a toy store, but they have these intense little magnets. They're like assembling toys, right? Never ever let toddlers do that because they'll eat stuff, right? Just like cows. Toddlers and cows about the same, right? Okay. They'll stick stuff in their mouth. They'll eat it. One magnet's not a problem. It's the second magnet, right? The intestines do this and that and this and that, and eventually those magnets get close and they go bam, and they're super strong, right? And so they perforate the intestine and the kid dies. Right, so magnets in kids. Honest to God, there's more than one fatality. So it's a huge, it's a huge thing. They've got to make sure that the little magnets don't get loose. So like those magnets, we have these insanely strong magnets on our refrigerator, right? I mean, you could hold a plate to the refrigerator practically with them. I mean, they're just really strong, right? Got to be careful with those. Okay, polarity of a magnet. There we go. Okay. So we have a shocking revelation, and this might offend the religious sensibilities of some people in the room, and so if you choose not to believe this, that's okay. Okay, but if the North Pole, why is the North Pole